In this problem, we are given that the velocity of a given particle is a function of its position along a straight line. And we are told that at t equals 0, the position is s equals 5 meters. And we are asked to find the position at t equals 6 seconds. So we are asked to find out what that position is. So looking at our various configurations of how we can define the velocity, we're looking for a term where the velocity is associated with the position. So we have, by definition, the velocity is the time rate of change of the position, and we can rearrange this such that we have dt equals ds over v, and in this case, v will be a function of s. So when we do that, we can integrate both sides. So in this case, we are going to make an integral of dt, and this is going to be from 0 to 6 seconds, and this is going to equal the integral of 1 over vs ds, and at time t equals 0, s equals 5 meters, and we are looking, I'll just call it sf, for the final position when we reach time equals 6 seconds. So we can go ahead and put in our information. So over here we can write this as the integral from 5 meters to s final. Well, it's 1 over 5 over 4 plus s ds, which of course I can take this fraction that's in the denominator and flip it around. So we will be given our integral on the left-hand side is over dt, so 0 to 6 seconds. And on the right-hand side, we have the integral from 5 meters to s final of 4 plus s over 5 ds. Now we can work out or evaluate both of these integrals. So on the left-hand side, the integral is t. We integrate dt, and we get t, and it's going to go between 0 and 6 seconds. And on the right-hand side, this is a 5. And we are going to have 4/5 s plus 1 over 5 times 1/2 s squared, and this is going to be evaluated between s final and 5 meters. So this will give us, on the left-hand side, it's just 6 seconds, and this will equal, so 4/5 of s final plus, well, the 1/5 times 1/2 is 1/10, so 1/10 of s final squared, and this will be minus 4/5 of 5 meters plus 1 over 10 times 5 meters squared. So we just need to simplify this, and as we'll see, we're just ending up with a quadratic equation. So this will give me 6s equals, I guess we can utilize decimals at this point, so 0.8 times sf plus 0.1 sf squared minus 4 minus, so this is 25 over 10, so minus 2.5. And we can now write this as a single quadratic. So we are going to take the 6s and move it over to the right-hand side, and just rewriting so all our unknowns are on the left-hand side. So 0.1 sf squared plus 0.8 times sf, and this is going to be minus 12.5, and this will equal 0. Now we can go ahead and solve this quadratic. You can either use the quadratic formula or your favorite solution tool, and we will find out that we have, of course, there's two values. So sf will equal 7.87 meters or negative 15.87 meters. So which one of these is the right answer? Well, we should go back and take a look at the initial discussion that says the particle is traveling to the right along a straight line with a given velocity. So that means we have a particle here, and it's moving this way in a positive direction. So we'll assume that to the left is positive s. And then we take a look at its velocity term. So if I take a look at the actual velocity term, v as a function of s equals 5 over 4 plus s. We'll note that for all values of s greater than -4, Vs will always be greater than 0, which means that the particle will continue to move to the right. So in this case, for my solution, we're going to assume that the particle has not moved to the left, which would be in the negative direction. So this is not the answer we're looking for, but rather the answer is going to be 7.87 meters.